Hello, everybody, and welcome to Documentation Not Included. It is Thursday, 7 p.m. BST, although we're getting closer and closer to that not being the case. And we are live on twitch.tv/DNI stream. It's time for our next show in our development series, which is episode 2.14, Proprietary Tools, Stagnation or Growth. I am Josey Howarth, and as always, I am joined to the strongbow to my white lightning, Chris Seabach.
You could have said Scrumpy, you could have said any craft ciders, but
I couldn't think of, like, I could have said Copperberg, but, like, my brain just forgot.
That'd have been better. Copperberg, it's slightly classier. Yeah. But anyway, good enough. At least I'm not a white lightning. Right, so yes, hello Josie, and hello to everybody in Twitch chat. As always, please do get involved if you have anything relevant or interesting to say. We will possibly read it out and get you involved with the show. So before we get started, let me please introduce our guest. This week, we have a guest that is a regular listener on the show. We've mentioned him many, many times, so we've got high hopes that he'll keep us entertained and and will provide lots of interesting content for us today. So, Bjørn, hello.
Hello.
Please do introduce yourself. Tell everybody why you're here and what you do.
Yep, as mentioned, my name is Bjørn. I work as a software developer with industrial automation, specialized in ship systems and the marine sector.
You make ships go fast.
So this is the PLCs that Josie's mentioned a few times on previous shows. I still don't know what PLC stands for.
Programmable logical controller. It's
So there's nothing to do with ships necessarily. It's something to do with the integrated system.
It's like a dumb computer, really. It's often how to put it. There's no operating system on many of them. It's simple. It is made to be secure.
So it's a piece of hardware that it's essentially an integrated system. It's a piece of hardware that is built for a very specific purpose, and it's locked down. It doesn't have an OS. Doesn't probably have a post or a BIOS or anything like that. I imagine. No. Interesting. Something I've never touched. I had absolutely no experience whatsoever in that, so I'm probably going to be out of my depth here.
I highly doubt that,
we'll see.
Considering our topic. But yes, before we go on, can I just say, Chris, I appreciate the fact that last week you realized that I would have had your guts for garter if you hadn't used an icebreaker question, so I'm so proud of you. But I also had never really heard guts for garter before, so that just stuck with me and it made me laugh. Yeah. So yes, before we begin, we have our icebreaker question as always. And this time, the icebreaker question really has to do with technology, but in a weird way. So, would you rather live without the internet for a week or without your phone? And yes, they are different things. So, without your internet for a week or without a phone?
Guests honor, Bjørn, what do you think?
For me, that would be simple. I would get rid of my phone for a week.
You would really want to keep your internet then?
Between those two choices, definitely. The internet has, the phone has more potential to find me and drag me into something I don't want to do.
You mean like work?
I'm in agreement. I'm absolutely in agreement there. But I'd rather not. If for a week, I would have preferred that question to be something like, "Would you, no technology for a week or something else?" They're both one and the same to me.
It's easy for you, Chris. If it was no technology or technology, you go no technology in a heartbeat.
Yeah, but I mean, I love my tech. Don't get me wrong. My house is full of it. I'm not one of these who has like a Alexa and home automation systems and things like that. But I'd easily prefer having the internet than my phone. I these days have all my notifications turned off on my phone. I uninstalled most of my apps that like Facebook and Twitter and LinkedIn and everything like that. I don't have any of them installed. I think I might have Facebook on there still, but I've turned everything off. I don't even have email notifications now because I don't need them. My life's better without them.
See, that's interesting. For me, I think it would be rather interesting because I would go without the internet for a week. And the reason why is because 99.9% of the people in this world don't actually have my phone number.
Fair enough.
So if I went without internet, they'd have no way of reaching me. And if I went without, my phone, they would have all of the ways to reach me. So I would actually basically end up with, in your case, defaulting to your response of no technology at all at that point because I wouldn't have to worry about it.
There's actually,
But
I don't really get
I would still be able to play games because you don't need the internet to play games.
Some games.
Some games, but that's a whole nother topic. Oh, wow.
Right, okay, so on to today's show topic, developing with proprietary tools. I'm amazed I said that right. I can never say the word proprietary, so I'll probably get that. I'll probably mess that up a few times during the show. So, Bjorn, quick question for you. Why did you pick this topic specifically?
Well, as a PLC programmer, you are pretty much forced into working with proprietary tools. Each PLC manufacturer has their own software development tool that you need to be using to make software for their product.
Right.
Because I could theoretically do development in Notepad or something, Visual Code. You do get plugins for Visual Code that makes it possible to do development there, but it's not practical. You lack all the functionality that you need, and I think the PLCs are more sandboxy than what you see in other development platforms, C++, Java.
So when we're talking about a proprietary tool then, or are you talking about proprietary languages as well?
Well, there is a language standard that we use. Manufacturers actually implemented them for the most part, and then they go their own way and make
Right.
they make special cases for their product, which make it difficult to change platform, and because you have to rewrite a lot of code.
Yeah.
So
almost follow the standard, but not quite.
See, Chris has never actually seen one of these things in action, whereas I have literally seen these things in action being built. And so if I were to say to you, Chris, I would like you to build a tool that when the house temperature gets to 80 C, you kick the fans on. Just auto turn the fan on. So basically an automated system. Would you be able to write something like that in C?
Yeah, absolutely.
And would you, have your choice of, what types of platforms you want to use and what types of devices you might want to use to make it happen? Like you might decide to use, I don't know, IFTTT, or you might want to use, you basically have choices, right?
Yeah, I've got a very wide choice in a generic kind of higher level language. To do anything, I can integrate with many APIs. Most of my job is finding the right API for the tool, for the job. Sorry.
Having watched some of the things that Bjorn has had to do in his time, and please, Bjorn, correct me if I am wrong on this, because this is what I walked away with, besides my head wanting to explode, was you have to pick which input is going to be connected in and pull that information from that input. You then have to almost say, use this particular circuit to then cause this device to then, it's so much more hardware level. Obviously,
it is very hardware oriented, and that is one of the reasons,
resistors and weird stuff.
Why we also probably need at least some level of proprietary tool to set everything up, because when a typical small project for me would be that I write a piece of software, I define all the sensors, all the I/O systems, do the hardware configuration, and then I need to start linking that into my software.
So you're almost writing device drivers then in that case?
Yeah, most of if you start looking at the modern PLCs, you will probably find something like an STM32 ARM processor in the background running most likely C and C++ code. Then you have on top of that you have the typical PLC languages that runs the logic part.
Yeah.
And
So-
you also you work in a very protected environment. You don't have that opportunity to mess up like you do in C or C++ and similar languages.
Okay, I have to quickly question in on that one, because there are going to be some people who are so used to sort of like the development frameworks that we talk about, things like Angular, etc. And some of our listeners are actually people who build the software side of things that have no Angular or JavaScript in them. And yet what you're talking about is something a little bit deeper than that. Now, you said you have less of a chance to mess up. I'm curious as to why you say that. Compared to C or C
I would imagine
or...
because you're limited in what you can and can't do.
Exactly.
Within that,
it is the limitations. Say if you want to make something dynamic, like automatic a config that would dynamically change the scope, for a better word, of your product. Like if you had 1 motor or 10 motors, you could just automatically change that. That's normally what you do easy in C and C++. It's not that easy to do in languages I do. Things that comes to memory management are usually locked away from you.
Okay.
You don't have to think about stack and heap. It's not a concept.
So would you say that the languages you use are high level or low level, because you're interacting with hardware, but are you interacting with that hardware via an API, or are you interacting at the, well, what would have previously been referred to as at the bus level or at the IRQ level previously? I don't know what it's called these days. PCI level, isn't it? I suppose on modern PCs.
Something like that. Oh, IRQs, man, that brings back memories. But anyway,
there is a level of code beneath what I do that actually handles the actual CPU and logic on that level.
Right.
Structurally, the language I use, the structured text, it feels a lot like C.
Okay.
But of course, with a lot of limitations.
So I mean, I don't interact with memory. I don't interact with hardware. I interact with APIs that that do all of the really low level stuff. So I can't really damage a computer. I couldn't if I'm writing assembly. It's very, very different to writing C# or even C++. I don't do C++, but it's a similar kind of concept. But C++ is again lower level than C#. So. And then we've got JavaScript and everything that sits on even on top of that, which is completely, I mean, you can go into, you can run it on a server and interact with hardware, but it's not the same thing. It's still abstracted away.
Yeah, I mean, you're not sitting there specific, like, for example, if you make a call and any of the things that you've mentioned to a database to, let's say, just grab some information from the database, you're not sitting there saying, I now need you to move the information found in memory block C.
Yeah.
Like, you're nowhere near down that. We've got the compilers and all of the other things that we actually have that handle those.
The lowest level I ever need to go to is I need to sometimes know the difference between a reference and a value type, and how they're handled in the stack or if they're handled on the heap. Very rarely I need to worry about that, but I can worry about that if I need to. When you're doing C++, it's different. You do have lower level management of memory and address spaces and things like that, but it's not something I've ever needed to care about. I just assign a variable, do something with it, and it's extremely memory hungry, but that's just the way the languages I work with. So, and what I'm trying to get to here is what I'm trying to figure out is how abstracted is it from the hardware? If you're interacting with inputs on hardware inputs on a cable, do you work with serial cables, or I mean, what kind of?
That varies a lot.
Right.
Do you have in its most basic form, it's like switches on and off. It's you get an electrical signal on an input, and your variable that is bound to that input just goes from false to true.
Right. So yeah, you've definitely got an API sitting on top of the hardware layer then in that case.
And the logic side of it is fascinating.
So this everything you're saying is pointing me towards integrated devices and or a more modern take on this, which is used by hobbyists, which are the Arduinos and the Raspberry Pis of the world, because you can plug things into them and you can play around with different.
I wouldn't necessarily throw Raspberry Pi into the same mix as that. I wouldn't. But
the Raspberry Pi could probably do most of the things that my PLCs do, with a little help of extra hardware. The difference is that PLCs are built by and complying to industrial standards. They can handle the rough environment.
Right.
It just as much the electrical side of things as there is the software side of things.
So we're talking about devices such things like Cisco routers, for example. Some Cisco routers can be deployed into extremely hazardous environments, minus 40 degrees Celsius, plus 50 degrees Celsius, that kind of thing. And they still work and they still operate, but they are specialist devices, but they have a pre-built operating system on them that allows you to do certain things and uses their proprietary tools, their proprietary frameworks, and sometimes allows you to extend them with C++ or various other languages or other binaries. But usually you have to speak to the vendor very, very closely to get anywhere near that. I've actually had experience of that in the last year, in fact, working closely with Cisco to figure out some cutting edge computing. So is it anything like that? I mean, do you deal with the vendors and the...
Not that much, I would say, because these devices are out of the box. They're not doing anything. They just have a power light going on, and that's it.
Right.
We get the hardware, we build it to our specification, and then we add the software to make the machine do what we need it to do.
Okay.
Be anything from power management systems to making the propeller systems for boats, flow control for water and similar stuff.
So that's interesting to me because, I mean, when we look at things from a proprietary standard, like if you want to write in JavaScript in today's day and age, pick your framework, have fun, that kind of a thing. However, if you're dealing that much further down towards the hardware, like, what you're saying there, SCADA systems, even that kind of a thing, you're going to get closer and closer to the proprietary side of things, because the people who develop the hardware that you're going to be using are, besides using correct specifications based on, this is why we have standards, my friends, this is why we need to support standards and environments. But you have, they know what their systems are certified to handle. So like, if you're going to be sitting there saying, well, I've got an electrical input coming in and it's going to be false or true, and it's going to go back and forth really, really fast based on whatever timing sequence you guys have set up for that kind of input versus output, the board needs to be able to handle it. The hardware needs to actually be able to handle it. In a way, you're almost writing the CMOS and the BIOS for these systems. So when you're dealing with that kind of level, it makes more sense to me to have a proprietary tool, or you literally divide the IDE, a proprietary IDE, in order to make the best use of whatever piece of hardware you've been given. Unlike when we all pick what operating system we want to use on a motherboard. We're not telling the motherboard how to handle memory,
Mm-hmm.
Does that make sense? Like, why would you want to have a proprietary system? It's because you have to have for something like that, because it's so close.
Can I ask a question, a slight follow-on question before Bjørn answers, that you can answer at the same time? Would you prefer to work with more open language, and do you feel like it would be appropriate? Or, what Josey says, is it absolutely necessary for you to work in these proprietary environments?
How to answer? At the
Carefully.
Okay, so at the moment, I'm in the process of going through a platform change with the PLC manufacturer. The one we're looking at, they are using a third-party programming tool that they add their stuff to, like hardware configurations and stuff like that. What I'm seeing is that there's a more open platform. You can go into their home address and download their pure version of this programming tool, and it is a much, because it's more open. It's also more people involved, and it has a much more modern approach to industrial software development, adding more features that you would expect to see, like object-oriented programming is like what are you talking about?
Well, object-oriented programming is quite heavy anyway, so I imagine in an integrated system, it's better to be functional or procedural.
If you look historically at it, PLC systems are very low-end hardware as well. It's a little bit of memory, it's a little CPU. It has just enough to make it work. You put your logic in, it is supposed to be running no matter what happens. There's not supposed to be any memory leaks. There's not to be any other software crashes. Everything needs to be rock solid.
Mm-hmm.
As the PC world has gone forward, so has the hardware available for the PLC manufacturers. Memory is a luxury that has come. I don't have to really worry too much about spending too much memory like we had to before. The CPU is more powerful than you usually need. So you have more.
Thing?
It gives you more leeway, I think, to make more. How to put it?
I think
more advanced software, probably.
With a limited memory footprint, though, you will only be able to write so many lines of code and manipulate so many variables or whatever I'm assuming you use some kind of variable system within that code. With an enterprise system, the kind of stuff that I work on, usually you're working with octa-core or 24, 36 core servers with terabytes of RAM, and you're running multiple VMs on this machine, and you've got so many threads kicking off at the same time. I imagine you're very limited in terms of the amount of threads. Multi-threading, is that even a thing in your world?
I've seen one PLC that has had it,
one.
Yeah, but that was a very special case where they ran Linux side by side with the PLC software, and had some memory, shared memory that you could use. So
yeah, I think it's interesting. It's a very different world. You're much more constrained with not just the environments that you program in, but also the hardware that you work with. But going back to Josie's question, is that a good thing? Is it necessary? Does it save money? That's the primary thing that businesses, I assume, are focused on here.
True.
Is it better to have a smaller piece of hardware or a more limited piece of hardware that's very robust, physically robust, in that it can be deployed into, it's waterproof, maybe it can be deployed into space or into environments that are harsh in some way, shape or form. It's easier to do that with less hardware, with more controlled hardware, than it is to do that with a server that does everything and has loads of headroom. Is that the reason why? Am I putting words into your mouth? I'm trying to figure out what the. I'm trying to figure out what the. Why is it a natural thing to do? I don't fully understand it.
I think originally PLCs were made to be very simple as well. That you need to be a programmer, software developer to actually work with them. They had a graphical programming language called Ladder. It's still part of the standard, and it is logically built around relay logic, like switches on and off, and it follows the same logic when you program the PLC. Right. It is made to make it easier for someone with electrical background to start program making simple software solutions. Today, what I'm seeing is a tendency that automation systems are gravitating towards PCs, Linux-based PCs, simply to get the tools needed to do everything. Logging is a thing, big data is a thing. We want to see how the system works. We want to log everything. We want to have the tools to analyze the data, both for the company that makes the system and for the customer, so they can analyze fuel consumption, electrical power consumption. They want to have the ability to, with a button press, get a report on what is going on the last 2 days for to send reports back to authorities for different things.
It's fascinating. It sounds very, very close to what I was working on with my transport client that I mentioned before. It's called edge computing. It's basically at the edge of a road, and it's integrated small devices or even big devices with a little bit more processing power that do a very specific set of things. But it is very much moving into this cloud-based, and there's also something called a fog as well, which is below the cloud, which is network. Basically,
not many people know about the fog.
No, the fog is a network that is close to. It's connected to the cloud usually in some way, but it is a roadside network or a network that is close to the hardware that it is managing. It's mostly being used in transport, that particular term, edge computing and fog computing, but it's very, very similar to what you're describing there. And it's PLCs, I don't know how big the industry is. I don't know how much money is invested in it in terms of the technology, but I can totally see that management want to start seeing the benefits of what enterprise do. They want to start seeing the reports. They want to start seeing the metrics and the throughput, and they have to pay for that.
Well,
exactly.
See, it's interesting to me because this actually brings up a story from way back in my younger years, back in the 90s. I don't say not, well, anyway, back in the 90s, there was a book that was released called Showstopper, and it was about Windows 95, or Windows NT. No, it was Windows NT. It was about Windows NT and about how they were unwilling to release a product to people if there were showstoppers and that, your bugging systems and things like that. Now, to me, that was a starting point for what an operating system was supposed to be: robust, sturdy, etc. So when I look at it from the perspective of the PLCs, you have that low level, you don't have a lot of options. You are forced to deal with whatever tools are given to you by the hardware manufacturers because they know what their particular pieces of hardware can do. And then the further and further we seem to go in the years, just because we have the memory available, or we have the CPU processing power available, or the internet throughput available, doesn't necessarily mean that we want to have things keep adding on top of stuff, which is what we're starting to see, at least in my opinion. I'm actually wondering if, because we've had these great Moore's Law, I believe it is, where we have all of the available stuff. I mean, Chris, if you wanted to build a fully integrated system that, sorry, trying to put the words into my mouth and they're not working right now. But if you were trying to build a fully integrated system and you wanted to have really fancy computers doing all of the work for you, you actually have options to have all of these computers integrate together, talk to each other. You could have them running off of graphics cards if you wanted to. I mean, there are massive, massive computational systems built off of graphics cards alone. However, if you wanted to, or just because that technology is available, doesn't necessarily mean you want to build to that technology. I'm really trying to find the right way to say it.
We've got two distinct architectures here. One's a monolithic architecture, which is a big machine that does everything. What we're now moving into, and it's very much, it's not the same as what Bjørn works on, from what I can tell, but we're moving into a containerized environment. And containers are very much, they're still operating systems, but they're very, very cut down, and they do one thing, but it's usually an application, and that application is still much more complicated than probably what I say about Bjørn works, and I don't know. So
that's what I was trying to get to, because what I was then going to lead into was, when you have to deal with a system where you are really stuck into whatever tools are designed for it, you do end up, it's like the thought just keeps leaving my head. So sorry, today seems to be me not existing. No, it's, you find yourself having to spend more time in development because each either container or each PLC has to be explicitly designed for that one core purpose. Therefore, reusability is not always easy. Containerization, it's easier in today's day and age because of how it's set up. But I'm curious if reusability is a reason why you think you're starting to see more PLCs that have that. We have the logging now that you can do a part of it, or tools that you can have those things. That's I was trying to get to reusability.
Having more tools, like what you describe now, definitely makes everything more reusable. It's a focus that my company has been high on the list now, to make everything more reusable. Unlike a lot of software developer, we have a very small client base. Like, we make a system and we maybe sell 5 to 6 of them per year, which make we don't have the amount of feedback from the client, not to the same degree as you can get if you have a larger user base. Everything needs to work safely.
You can't do a day one patch, put it that way.
No.
Yet.
Once it goes
gold. Then, would you want to, for security purposes? I mean, one of the things you said was these things are meant to be a bit more secure.
Yeah. It's like, if we mess up, it can have very serious consequences.
Yeah. So is your QA process very stringent then, I'm assuming? Should it be more stringent than it is? I mean, there has to be a level of QA if what you're doing
there is all the systems that that we delivered, and they are tested as much as you can on the lab, and also during system commissionings. Everything is tested thoroughly, because we don't only have to take into account that there might be a software bug, but also like installation errors. There are thousands of signals that all needs to be correct, else the software can not end up not working correctly.
Of course, yeah.
Yeah,
it's very interesting. I think I can see a general high-level picture of how it works. I mean, I would never claim to be, an expert, but it's very interesting that it's a very different world to programming than the enterprise, and even
definitely is.
Would you consider it programming or scripting what you do? Do you write a list of commands, or do you write functions that do things and then call those functions, if you know what I mean? And that isn't really the difference between scripting and programming. I was about to say
that does not work, Chris.
No, because you can call functions in scripts as well, and the other way around. You can write programs that don't necessarily. I suppose they do they make calls, but that's about it. I strike that from the record.
Are you a script kiddie, or are you a program?
I suppose what I'm trying to figure out is do you execute scripts, or do you execute binaries and run those?
I execute binaries.
Right. Okay, so
I have worked with PLCs that actually do take the same language and run it as a script. It makes the PLC very slow,
I imagine. So it's interpreted in that case instead of being compiled. Yeah,
very, very easy to work with as for debugging, because it could just type a code and press a button, and it's like live in a second.
So have you ever been deployed on site to where the PLCs are being installed to debug something? Is that part of your job? Yeah.
My job includes everything from pre-planning the system, helping out with the schematics, plan out the software, do the software development, do the testing of hardware, commissioning of systems, and aftermarket support.
Right.
He is a one-stop shop. And just to put a thing out there about scripting versus programming, I had to look this up because this was going to get to me. All scripting languages are programming languages. The erratic difference between the two is that scripting languages do not require compilation.
Yeah, that's what I was saying, between binaries versus scripts, interpreted scripts versus a.
Also, thank you, Google.
Running calls in a binary file of some description. Okay, so we've talked a little bit about. Well, we've talked a lot about what you do and how you do it. I suppose, are there any other frustrations that you have working in that environment, in that limited environment? Are there any times when you've written something, or you've compiled a piece of code and deployed it, and you go, well, if only... Do you have enough knowledge about other programming languages and other frameworks to know that you can do this in something? Like, I could do this in C++.
Unfortunately, yes.
Right, so why can't we just use C++? And what's your take on that? Do you get so frustrated that... Sorry, not frustrated. Do you get to a point where there's ever a use case, or there's ever an argument that you can put forward to say, we should be using something else here?
The way I see it at the moment, I don't think there's a lot more to it than I could do a lot of things with an embedded system, like running C code. I could make it a lot more flexible and probably develop a lot of things quicker. The wall I'm hitting there is product certification, product approval with different classing companies like DNVGL, and similar, which is a marine quality assurance company, you could say.
Okay.
It would make it a lot more expensive to work on platforms that are not certified.
Yeah. So there is a monetary element to that then.
Yeah.
I would assume, this is my guess, that 5 years in the future, 10 years in the future, I will probably not be working with PLC languages anymore, and rather be working with C, C++, or something similar, Rust, perhaps. I've seen a lot of people talking about Rust as a language for embedded.
Yeah, I've seen that myself recently as well.
See, I'm now wondering, you know, I know of some people who actually program hardware, like the motherboards and things, not just the PLC boy here, which I like to call him in my brain. He is PLC boy, or Moose, whatever. But in this particular case, you know what? When I hear you saying that, there's a part of me that goes, that's really cool. And there's a part of me that gets really scared. Because when you start pulling further and further away from that kind of close to the board language, I guess, is the only way for me to phrase it, it almost feels like you're introducing avenues for more trouble. You know, more errors or more bloat, or, you know, will we have someone go, well, I need to get more memory so that I can, you know, power my airplane. You know, like it just makes me wonder if that's a good thing or a bad thing. I mean, I don't deal in the PLC world. I don't deal in the hardware development world. So I don't know what advancements may have been made or not made. So do you have any thoughts on that?
There are ways to mitigate issues. One thing that was introduced to me was a coding style guide for C++ that was made for the software running on the Joint Strike Force airplanes, or whatever they call. I can't remember the exact name. It is like a long document describing how to program to make it secure. Like, functions shouldn't contain more than this much variables. A class shouldn't be more. It's very, very strict. And this is to make the software very, very solid. It is a set of rules that will.
Right, this doesn't make sense to me. I mean, I know I'm just hearing a high level thing, but that the only reason to do things like that, like reduce the amount of variables and reduce the nesting, and, you know, make sure you haven't got
it makes limitations, but that you still have a lot of the flexibility that these languages introduce.
But to me, that all that does is it helps you maintain the software going forward. It gives you standards to make it easier to maintain, and makes it easier for teams of people to work on the same piece of code. It doesn't make it more secure, unless you've got a very specific, you know, you must encrypt particular pieces of information, or you must declare variables in this particular way. You know, it must be a signed variable if it can't be a minus number, that kind of thing. But I'm struggling to see how that would make a difference, unless I'm missing something. I probably am.
There's the thing that stands out for me. One of the things that ends up introducing so many security vulnerabilities in our world is the fact that you will have many people working on the same thing, doing what they think is right for their particular part of an application. So when you need to have a very easy way for everyone to know, you know, how everything is structured, what is expected of me for this code, having standards makes perfect sense. You know, it's a bit like when he was explaining to us how by using the proprietary tools for PLCs and things like that, he's stuck only making the right function calls that the proprietary tool says can be made for that piece of hardware. And if you apply that, although getting humans to ever do what they're supposed to do is a whole different story. But if you say that when we work on this particular application, whether it is something for the DoD or whether it is something for your local grocery store, makes no difference. If everybody is following the same standards, it makes it a lot easier to secure, because you actually know how everything is going to be structured, which tells you the types of tests that you need to run or the things that you're going to be looking at. It just makes it easier. It's less of a chance to have that function that shows up that says, I don't know what this does, but if you delete it, it breaks everything.
Yeah, well, that's a maintenance thing. As I said, it's not. I'd like to see that document. I'd like to understand where I'm misunderstanding, I suppose.
Yep, I'll get you the link.
Yes, drop us, and we'll put it in the show notes as well for everybody if you don't mind. If it's not proprietary, at least anyway.
No, it's fully open.
Well, even if it's proprietary, it doesn't necessarily mean you can't access it.
Well, okay, if it's not secure or private, or internal or anything like that. It's just interesting because I find that the more tools and the more knowledge I have to my disposal, whether it's across the languages I use and the frameworks I use, or it's other frameworks, languages, tools. This is one of the reasons I do this podcast, is so I learn what other people do, so I can get better at what I do, because I've got a broader set of information. The more information I have, the more informed decisions I can make. And security, liaising with Josey for quite a few years now, has become... it always was important to me, but it has become much more important to me. And that is reflected in the code I write as well.
That makes me so happy. Yay!
You'll be proud of the stuff I've been doing the last 2 weeks, Josey, I tell you.
Go ahead, Bjørn.
Security is also something that is starting to show up a lot more in industrial automation systems, because traditionally it's been a no topic. So thanks to Josey, there have been changes made at my company as well. So
this is a happy celebration day for me, flowers and rainbows. And I think there's something to be said for the whole concept of proprietary tools. I think they have a purpose. I just worry that people get stuck in them and can't learn and grow and maybe go on to do writing for another company. We didn't really get to that point in our topic, and the only reason why I bring it up is because we are kind of at the end of our show. So, yeah.
Well, why don't we end the show and have Bjørn back in the future to talk about the purpose and the reasoning behind why we would use proprietary tools, and again the stagnation, which is part of the topic, stagnation or growth. We didn't even cover the subline.
No, we didn't. I was much more interested, trying to get him on the show.
It's fascinating to some. I said it's not going to be fascinating to all our listeners. It's not going to be fascinating to everybody, but it's something to me that I'm interested in. I want to know what other programmers do, because I'm not the be-all and end-all, as much as I may come across like that on the podcast.
No, you're perfect. It doesn't mean you have to know everything, but you are perfect.
So
that's the way it works.
It's still really fascinating to dig into this, and I think maybe digging into the industry, where these tools come from, and how do they stagnate. That's maybe the next topic that we'll cover.
Maybe, yeah. And to go back to what you were saying, Chris, and this is the thing that I think at least stands out to me. You and I may not do anything close to what Bjørn does in our day-to-day life. However, we've now gotten an understanding of something that we didn't know before. We're able to relate it to things we know, which literally breeds innovation. You can't work with something you don't know about. It just doesn't work. So to me, learning about things like this and sort of understanding how things work, it's obviously so interesting, because you then go, well, how do I make this happen? And then we get people like Bjørn who send me messages going, so that thing you guys talked about, so how would that work in this environment? That kind of stuff is what fascinates me, and it's why I love Documentation Not Included. But now we're going to shift gears entirely. We're 180ing from yay to, are you really kidding me? It's RTF time. Time for us to rant about anything that may or may not be bogging us down, that may or may not want us to rip things to shred and apart. And it doesn't have to always be about programming. It could be about, your favorite drink got canceled. I don't know. Do you have an RTFM today, Chris?
I mean, other than, I think I might have used it previously, but currently renegotiating contracts 2 days before the end of my contract renewal, because clients basically don't really know if they want to keep me. They know they want to keep me on, but they haven't got their ducks in a row, basically. That's my only RTFM at the moment, but it's just a standard thing for me a lot of the time. If I'm with a big company, it tends to be a lot earlier. They've got departments that deal with these kind of things, contract renewals. But when you're with a smaller company where everyone's doing everything, they don't have the time to sort it out. Communication and everything is
all the things. I'm not actually frustrated at the moment. I'm actually feeling quite zen this week in particular. So, yeah. What about you, Bjorn?
Not programming related. I'm going to say one thing. Winter is coming. It's starting to get cold.
Is it not always cold where you are?
Isn't there always snow on the ground where you live?
Yes, and I have polar bears in the backyard. No, not quite. But
pretty darn close. How far north you are?
I'm getting close to where I actually had to get ice off my car in the morning. So that is going to be my rant for the day.
Weather.
Yeah.
Or mine has more to do with the fact that at times it just seems like translation is out to get you, especially when you are the one implementing translation for a client. And you really want to do the best job that you can, but you can't always trust the translations that are sent to you or the tools that you need to use in order to implement the translations. And translations. And it sucks. I love the fact that we all have different languages, different dialects, and I don't ever want that to change. But so help me God, I have such problems when it comes to actually implementing them to the standards that I want to have.
Try implementing a localization system in an enterprise-grade piece of software. I've just been doing that. I've been trying to design how languages should be presented. And because of the different types of users and the different audiences, some people who are the audiences of the software aren't actually users of the software. They don't officially have an account or anything like that. You have to, in the database, you have to designate default languages, and then you have to do the translations and then localize the actual applications and figure out how to present the information. And then you've got Unicode issues, which we were discussing slightly before the show with the I'm not sure what it is. Is it an O? The Bjorn, the O in Bjorn? Or I'm not sure if there's an official name for it. There must be.
It's So it will be Björn, not Bjorn, but yeah.
So Bjorn.
I'm going to butcher your name no matter what way we go about this.
So, but yeah, it's difficult. It's a difficult problem because people are involved. And that is what software is. Software is the translation between computers and humans.
Yes.
And it's that you'll never solve all the problems.
No, you won't. And when you start getting into, like, for example, in one of the systems that I'm working, or one of the clients that I'm working in, it's not just things like French, German, Spanish, yada, yada. It's also things like Japanese, Korean. And that goes from being LTR to RTL. For those who don't know what that means, that's left to right reading, to right to left reading, which can drastically change because you can't always mirror. But it can drastically change the actual UX of a system or a website or what have you, based on whether it's an LTR language or an RTL language. And it's crazy. So, woo! Woo! Surprise! Yay! All of the good stuff. We have officially reached properly what I would hope is to be the end of our show. Although, honestly, I just want to keep talking about PLCs because I get fascinated by listening to him talk to what he does. But anyway, thank you to everyone in Twitch chat for joining in. El Gordino and Ossie and Envina. Hearts and loves to you all. And to everyone listening to us in the future. And thank you, Bjørn. I'm totally gonna, I'm going to do that to you for a very long time, for joining us. I do hope you have had fun. I know being a listener, it can be very nerve-wracking. So hopefully you had fun.
Yep, I had fun.
Good stuff. Hopefully we didn't drill you too much.
Nah.
And I purposely am not asking him to pimp anything because he's a bit like Mark Walsh. So, Bjørn, do you have anything to pimp?
No.
It's that simple. It's just no.
But we do have things to pimp because we are shameless and it's all about us. So you can visit our website on www.dnistream.live where you can get links to everything, all our Discord, all our platforms, discovery platforms, etc. You can also use the contact form to get in touch. I'm not sure if Bjørn sent us a contact form, but he probably just sent us a message in Discord, I would imagine, to come on the show, or another way, maybe.
I don't stalk him at all to try to get him onto our show.
Okay, Josey has been sending message on a daily basis on every single way that she possibly could get a hold of him.
Pretty much.
So yes, you can use the form to give us feedback, send us a funny dev story you want us to read out, or anything that you didn't get to say during the live show that you might want us to say. Or you can talk about coming on as a guest, as we said.
Did you say use the phone?
No. What's a phone?
I literally think you said you can use the phone.
I didn't.
To reach out to us, which honestly you can't right now.
You can't because Josey's got rid of a phone. No, we've got rid of our phones. You kept your phone, haven't you?
I kept my phone.
Yeah, you kept your phone.
Now the piece is coming into place.
Yes. But yes, okay. So thank you, everyone, for joining us. We hope to see you next week at Thursday, 7 p.m. UK time, twitch.tv/DNIstream. I thank you, Bjørn. Thank you, Chris, for being awesome and perfect.
Can't help it.
All that's left is for us crazy people to say in a discombobulated way, bye-bye.
Bye-bye.
Have a good one, guys.